Right, so Mangone has his presentation. Paolo Vineis, Cathryn, Tonne, Rossella, Alfano, Alexandre, Strapasson, Christopher Millett, Joan Woods, and Onesmus Mwabonje, integration of multiple climate change mitigation actions and health co-benefits, an exploratory framework using the global calculator. So let's explain us what's this global calculator.
Sure. Is it? It's. Is the slides are not loading for some reason? Wonderful. Hello, everyone. Thank you so much for the introduction, Prisco, and thank you all of us for attending. I am a PhD student at Imperial College, and what I would like to discuss with you, it's a study that we've done on the prioritization of policy actions to tackle climate change. The reason why we decided to do this study is that, as we all are well aware, the current policies seem to be widely insufficient in actually achieving any of the goals of the Paris Agreement. In the latest IPCC report, it is stated that there is both an ambition gap and an implementation gap. So we are not taking actions that are aggressive enough to tackle this issue in the time span that we've left, and we're also falling behind on respecting the goals that we've set for ourselves. So we're not ambitious enough, and we're not even able to do what we promised to do. Climate change, as we are all well aware, is responsible for incredible health outcomes. And at the same time, there is another face of the medal. So trying to mitigate climate change can lead to substantial health co-benefits. And we believe that it is extremely important to take the health co-benefits and use them to reshape the narrative around climate change mitigation, to show that doing something aggressive, doing something right now, does not just lead to some nebulous effects on climate 50 years down the line, but can immediately lead to some pretty substantial effects on health of the population. As it was discussed yesterday, the issue with palm oil, it became relevant when people felt that it was impacting them in that exact moment. To try to tackle this issue, we decided to use system dynamics. And system dynamics is an approach in which you're combining a lot of models, you're integrating them in one unified larger model, and using this larger model to answer to some question. The global calculator is an example of system dynamics. It was launched in 2015 at Imperial, and it has been the base since for many single country level calculator, in which essentially you're combining models for the energy system, for the food system, for demographic changes, for manufacture, for industry, into just one larger unified models that allows to estimate in a very rough manner the cumulative emission of greenhouse gases on the base of some levers that in our case are policy and lifestyle changes. It is freely available online. You can just Google global calculator and you will find this page. It is composed by 15 different areas for a total of 43 different levers. Each lever represents one possible policy or lifestyle change with different levels of ambition. One is a business as usual, scenario for what it was in 2010, so nothing is being done at all. 4 is the highest level of achievable change for any given area. So 4, it's almost unachievable, but with enough commitment could be done. 1 is let's do absolutely nothing. What we've done is to toggle all these 43 different levers by changing the level of ambition by 0.5, 1, or 1.5, compared to a business as usual scenario that in our case was the IEA 4DS. So the model from the International Energy Agency that was following the commitments that were taken in 2014, I believe. By doing so we did it for each lever separately and for all the levers that compose one of these larger areas, so travel, homes, diet, as a whole. You can see, for example, the change induced by a change of 1 in the travel sector, in cumulative emission in 2100 and in yearly emission in 2050 due to changes in both energy supply and energy demand. To try to answer the question of what the potential health co-benefits could be of all these different policy changes and lifestyle changes, we have used 3 different tools. We use the global burden of disease. That is one of the largest initiatives that has been done to quantify the impacts of many potential changes. We use the carbon co-benefits calculator from the University of Leeds that allows for the quantification of co-benefits in many different areas and in many different sectors, so on biodiversity, ecosystem, but specifically health. And we use the low carbon living calculator from the University of Melbourne that is more focused on quantifying the changes related to transportation and urbanization. So they're all complementary. They all capture different sides of the health co-benefits. And we were hoping that using them together could help us paint a better picture of what the health benefits of climate change mitigation could be. You can see here the comparison of intervention according to the global calculator. This is the scenario +1, so increasing the level of ambition of 1 for each different sector. You can see quite clearly that not all the sectors have the same potential of affecting climate change. Some sectors have almost negligible impacts, while other sectors have immense impact and can decrease to a reduction in yearly emission by almost 40%. Specifically, the highest reduction in yearly greenhouse gas emission can be obtained by intervention on the food, diet, and land use sector. Specifically for food, the most important driving factor was meat, cattle meat. For diet was the total amount of kilocalories, and for land use was the efficiency parameter of the land. And followed by transition to renewables. I don't have the percentage here, but it should be 21.6%. While the interventions that have the lowest impact are carbon capture and storage, changes in transportation, the use of nuclear energy, and bioenergy. On the health co-benefit side, all the different tools that we use seem to capture that impact, that changes in transportation can lead to pretty substantial health co-benefits. Changes on diet, buildings were also quite important, and something also changing the way in which we travel and the way in which we use the land seem to be pretty important drivers of health co-benefits. In conclusion, we identified some areas that we believe should be key priority areas for policymakers because they are the ones that change the greenhouse gas emission the fastest and that leads to more substantial and long-standing changes. Specifically, the transition to renewable sources and change the way the AEF-OLU sector in general, so the way in which we use agriculture, forestry, land use, as more specifically food production. Something quite interesting is that carbon capture and storage and nuclear power are topics that emerge time and time again in the public conversation about climate change. But according to our models, they seem to have pretty modest role in emission reduction and very low potential for health benefits. It could be argued that transition to nuclear power can still lead to a reduction in pollution that has some important health benefits, but a similar thing can be achieved by transitioning to renewables that, as we stated, has more important effects on greenhouse gas emission. We believe that decarbonization still remains the highest priority. You might have noticed that there is no decarbonization axis in the global calculator. Decarbonization is distributed among all the 15 different levers. Should it be its own separate axis, it probably would outshine every other by far. But we believe that decarbonization, it's on a different level because it's not a single policy that affects it. It's affecting all the different sectors in a decarbonized centric mind that can actually lead to any important change. We are aware that our work has some pretty substantial limitations. It's quite difficult to compare different levers because we're talking about policy, we're not talking about models. So what does it mean to change the way in which you produce wind power versus solar power? It's debatable. And also, we're not using the model in the way in which it's meant to be used because our research question was to prioritize something. So we're not building synergistic scenario, but the greatest potential for system modeling is that it is built in such an integrated way that it captures all the different synergies that you can have by using policy in two different areas that affect the same model. And lastly, there are some modeling assumptions. So, for example, still producing enough food to supply the global population is considered a hard assumption. And so, since we did not affect at the same time food production and bioenergy, the bioenergy that we were capturing is just built on the leftover of whatever foods it's already covering, essentially. We would like to eventually update the business as usual scenario, moving from the IAA 4DS to something like Fit for 55, because we believe that the 4DS is quite updated. And we would like to reassess the way in which we are assessing health benefits. As you've seen, it's a semi-quantitative way what we've done, but it is possible to start doing so in a quantitative way, at least for some areas such as pollution and PM 2.5, and we would like to eventually do so.
Thanks, Lorenzo. Before you go,
sure.
Can you move to the previous third slide, before? This one?
Yep.
Here we see that diet has only a small potential on climate co-benefits portal, and if you move to the previous one,
yep.
Here is the highest reduction in emissions.
It's different. This is the global calculator, so this is on greenhouse gas emission, and this is just on health co-benefits. So this is just on the health side. It's probably also the way in which the climate co-benefits portal is built. So as you can see, the global burden of disease finds a very important impact of diet. Yeah. So we are not building these tools.
So we can say that it has both a very important contribution to the burden of emissions
yep.
and to the burden of disease.
Yeah, I think it's a very valid assumption. It's my entire research, so I would like to discuss it more.
Later I will explain you why and how nuclear power can have a burden on disease which is not comparable to the benefits it can have.
Okay, wonderful. Thank you so much.
Okay.